All right, let's get started. I wanted to go into a few more details here with what's it called? JavaScript JS placement. Right, so how do we actually get a large image into Dog Waffle if it seems to be failing when you just try File Open? Well, there's another option, and it's called General File Converter. That one usually thinks you want to export your current image, right? So now, right now, this one's blank, but let's say I'm doing something like this, and and I want to export that, right? So, you little devil, you, huh? All right, so let's go and export. Let's export this image through General File Converter. First thing it does is it makes a copy of itself. So this is in General File Converter, and it's its own application space, its own address space. You can zoom to fit, so if you make the window smaller, you'll still see the whole image. You can also copy it to the clipboard, and you can do other things like resizing it. Now, that may be particularly useful if you have just imported an image, not from Dog Waffle, but from a file, and you think it's too big and you want to make it smaller before sending it over to Dog Waffle, right? And that will eventually happen here. Now, if you make any changes, you can always grab it back, import from Dog Waffle. So this is basically a springboard or sort of an intermediate step between the Windows navigation, the Windows file system, and Dog Waffle. So let's go over there and open an image that we have on my Windows file system. And I'm going to look for a format that I should have. You notice there's about half a dozen of formats here: bitmap, GIF, JPEG, EXIF, PNG, and TIFF. Notice Targa is not included. These are the formats that Windows recognizes and can display in a preview window. Right? If you go to JPEG, for instance, and you select one of these images, remember you can have a preview here as well. And then there is a resize option here. And let's say if I go to PNG, I have many more images, and here they are. These are some of these large images. Let's go take one that's not too large. We've already resampled it down. This one's probably still the original 8K. Let's work with something a little bit smaller. This is a 4K, 4096 by 4096. These here, same thing. All right, so let's take one of those just to start becoming familiar with how that works. Loaded it in pretty quickly, even though I have a very slow system, 8 years old. And what I'm going to do here, you can click this so it's not showing, not zooming to show it all, so you can navigate at full size. But at any rate, you can, and then from here send it over from the image menu, connect to Dog Waffle, and export it there, right? Export to PD. And that will, in the lower left corner, give you a little feedback scroll bar, feeling good, doing stuff, and soon enough that image will be in Dog Waffle. Now, if on your system that crashes, it may be for a variety of reasons. It may have gone out of memory. This may take too much memory. Well, if you use Control Shift Escape, right now what I'm seeing is that Dog Waffle takes only about 244 megabytes. Look at that. That's rather unusual. I would think, no, actually that's about right, for a 4K by 4K image. Um, what is it? 4K by 4K, that's 16 million pixels. Each pixel has 3 bytes for red, green, and blue, plus an alpha channel, that's 4 bytes, plus the swap image, another 3 bytes. So 7 bytes at least. I don't know if it may even be packed into, adhering to byte limits of 8 bytes. So maybe it's 8 bytes per pixel or 7 bytes. But 7 times 16 million, that's probably 100 and something million. This looks like twice as much, so it's probably, well, I don't know, whatever the math amounts to, and it may not be everything we thought about. What I'm saying is that this is somewhat complex, and what you do want to worry about is whether you're going over 2 gigabytes or 3, possibly 2.5, somewhere around there. If you're getting close to gigs, you are probably in a danger zone. So very large images. This one here took about 250, 270. it's going to be over a gigabytes probably, or close to that, if you are with an image of 8K by 8K. So how do you work with this? You can certainly from here on do things like rendering this puppy ray like this, and perhaps we'll go and make it a little bit faster preview, no trace shadows. You can do a couple of things to make it go a little bit faster. For instance, global illumination may take a little bit longer because more details are showing, and it may not be the time it takes to render, but the time it takes to put it into the undo buffer. Now, why is that slow? Because in our case here, we've configured it to go to the hard drive for every undo image. Right? The undo mechanism is fast when it's in RAM, but you may contribute to running out of RAM if you do that. By default, it's using RAM and it's fast, but you may want to actually go to the hard drive with it to enable disk mode for the undo memory. All right, so here I'm doing a rendering, not a very smart area that I picked here. But you see, of course, it's showing the whole image in the preview. Here I'm at 100% without scaling down to fit it all in the window. So I'm actually zoomed in. It looks like zoomed in. It's at 100% zoom. It's not zoomed in, but it's a very large image, still at 4K by 4K. So once that rendering is done, I can zoom out a little bit and see the extent of the entire image. All right, so what's this thing with the undo? You see here there's an undo browser that shows you the stack of undo memory. And that one is usually in RAM, but I've configured it to go to the disk so that I can load even an 8K by 8K image. Do that from the view menu. In the view menu, you go to settings. Under there, you can go to memory settings, and you'll see the disk where it's going to keep those. That's the temp buffer, the temp folder. You can change that to another drive if you have a faster one, like an SSD drive. And most importantly, regardless of how much memory you say you want to use, that really doesn't matter so much. What matters is the fact that you're saving it to disk. So make sure you use the disk drive to store your images for undo. And you might even want to reduce the amount of memory on the disk, right? How many undo levels to use there. So how many at minimum you would like, and maximum as well. But most importantly, use the disk. All right, so once you've done that, you should be able to load very large images and not contribute to running out of memory by that additional 200 or 300 megabytes for the undo image. Okay, and then you may want to save it back. So again, go to the general file converter. I don't think mine is still running. I think I closed it. Yep. So I just see Howler running, and I'm going to go back to File, General File Converter. And from there, well, as usual, it's not showing the whole image. It's just showing a small portion of it. And what I'm going to do is zoom to fit to confirm, yep, that's the image I want to save. So you go back to the file and save it. And perhaps we'll say this one is a BMP, a 4K BMP. .bmp will be added. I can add it already here. And so at this time, you have a 4K BMP image saved out. All right, let's do the same thing with 8K. Now, because we're going to be pushing the limits here of memory, what I recommend, first of all, is you close the existing general file converter. And you also close or make the image much smaller, create a new image here, and say something like, something small. Just so that it doesn't already load too much and then try to load even more on top of that. That might throw it off the limits. Be prepared for occasional crashes. This is really where you're in the dark zone or the gray zone of where it may be running out of memory. Some of the tools you'll try to use will definitely not have enough memory, such as the Transform 3D Designer. That one needs a bunch of extra memory. Puppy Ray, however, seems to be working okay, and so let's go check that out. Let's go to General File Converter, and let's go to Open. And this time we'll go look for those large PNGs that came straight out of there. Let's see. Yeah, this one is pretty nice. Tooltip shows us it's 8,192, right? So that's 8K by 8K. Let's go grab that. And loading we do. It goes in really quick into General File Converter. That's a really optimized library that Microsoft has developed for us to load these images. And so that's already a blessing. And then the next thing we want to do is simply send it over from the image to connect, export to PD. And if we run out of memory, we'll just have to start from scratch. Right? That will happen on occasion. And if it doesn't, we're just lucky now. Now, you see in the lower left corner, feeling good, doing stuff. Again, my system is somewhat slow. The RAM is slow. It is about 1300 megahertz. Yours is probably over 2000. If you are on a high-end PC, like a gamer PC or high-end workstation, probably close to 3000 megahertz, maybe even above that. It's going to make a big difference. This is very memory I/O intensive. A lot of memory gets allocated, a lot of memory gets loaded and initialized with the image. You'll see at some point in the background the image is initialized, it's all white now, and then on top of that it gets a copy of the image. That memory allocation is what took quite a bit of time, I think. Whatever it is, at some point, patience is a virtue, and at some point we will see, now it's gray, so we can now actually safely close the general file converter and zoom out. And you have the entire 8K image. Don't believe me? All right, let's go here. Image info. There it is, 8192. All right, so we have a large image here. And there are some things you can do there fairly easily, and there are some things to stay away from. Do not use the fill tool. The fill tool is a recursive algorithm that is thinking it has an infinite amount of memory. Well, it doesn't. And so if you use the fill tool on such a large image, it is quite possible that you will crash it. Not always guaranteed, but it is quite easily seen. Now, what we really wanted to do is render this. So I'm going to do the following. I'm just going to filter, transform, PuppyRay GPU. All right, and there it is. Now, this is the preview from the prior render. I'm going to undo the anti-aliasing because it takes a long time if I make any changes, if I zoom out, if I move my camera, if I change the position of the sun. If I do anything, it takes a long time to render at this resolution on my poor old PC. Now on yours it may be a fraction of a second, or maybe a few seconds, nothing bad. But here I want to be careful not to have to wait, let's say 2 minutes for a single refresh after moving something. So I'm reducing it to maybe 10 or 20 seconds by unchecking the anti-aliasing. What else can you do that will save time? Trace shadows may potentially save time. Actually, ironically, it takes time to calculate the shadows, but by having the shadows or not shadow, by having the shadows, it may actually put some stuff in the dark and it may be faster to render. So it's kind of unpredictable as to which way to go there. One thing you can do is change the quality to a fast preview. Now that's starting a rendering, okay? And so it's going to take a few seconds and probably about 10 or 15 seconds or so. Oh, no, not even that much. All right, so we have our first successful rendering here. I'm going to go just to render, click a little bit rotation and look to the left. So I move or spin my camera to the right. That again takes about 7 seconds or 8 seconds, of which a good portion, by the way, maybe 2 or 3 seconds, is generating the undo image, right? Copying the current image before I actually render this in. So undo is not going to a fast disk in my case here. On your system, it should be an SSD drive ideally, and just be so much faster. All right, so let's say this is the image I want to render. Maybe I want to actually flood it a little bit more, so I'm going to move it down a little bit more. And you could try this interactively, right? Go here with the camera, and no, not move the camera, but move the world. So go here, and then with the right button, drag it down a little bit. But every little motion, if you accidentally first move up a little bit, it'll go in the wrong way, and then it'll be just another painful. Oh, I was lucky on this one. I bet it's doing another rendering. Oh no, it's already done. Look at that. All right, so now I'm gonna go to the world and change the settings for transparency. Actually, that's on the render settings. Here I want it, not here. I want it here with the refraction enabled. And with any luck, it did not automatically start re-render. So I can do a few more things. I could, for instance, go to the world and enable caustics, and enable caustics at about 6 or 7. And then also scattering, maybe do about 22 and make it a little bit darker, but still highly saturated, something like this. And that's probably a good start. Maybe a little bit of ground fog. And then let's go render that. There's plenty of other parameters I could want to try, but these are usually some of the places where I start. I'm going to go also render, let's say, something like wave height of 6, frequency that will be the sort of the equivalent or controlling the or the counterpart to the wavelength of the waves. So if I make it a lower frequency, it'll be longer waves, bigger rolling waves. What else could we do here? Well, let's render that and see if we distinguish a nice amount of distortion on the wave with the refraction. It'll be difficult. Oh, we see a little bit here. It'll be difficult to really see it until we go to the final quality. So one thing you can do also is trace the shadows. And do you want interpolation? Well, yes or no. There's a choice. Let's try without. Let's see what else. Maybe add some rocky or pitted appearance on those, like it's eroded. And then maybe one thing I'll do this time is, oh wait, it is rendering right now, so I'm gonna have to wait a little bit. There it is. And one thing I want to do is move it up a little bit, but not by moving it up, but rather by scaling it up. So I'm going to look for the scale option. Either I do this interactively with the left button vertical move, or you look for the world, and here's the position and the scale, SX, SY, SZ. So you can see the scale Z, vertical is in that direction, vertical up. Scale Z is a little bit small, so I'm going to go make that double the size. I'm going to say 0.5 and render. And that may help getting some of the data back out of the water. Oh, actually quite a bit of it. And it's also very broken. It appears broken because of the pitted look with the bump map that I added. All right, so 0.5 was too much. Let's go down to 0.35 and see what that does. Now at this point, it has grabbed the focus on the mouse and automatically re-renders when I made a change. Okay, so that one is actually in need of even less. So I'm going to go back down to, let's say, well, what was it? 0.25. Let's do that. And then just add a little bit. Instead of 2.5, I'll make it 2.6. 0.26. And that may be just enough for what I want. Or you know what? What you can do is you can scale it and then move it down if you want more vertical depth to it, right? So let's do, for instance, 0.28, which we know is probably going to move it out a little bit too high. There you go. And then if we want to move it down, instead of the scale amount here, we'll use the position. And maybe we'll say we need to move it down a little bit more, 0.04 instead of 0.03. And we'll see if that's too much and adjust that again. Oh, that actually is pretty nice. All right, so I'm going to use that. I'm going to then go back to, oh, no, looks like get another rendering. If it's not responding, it means it's rendering and busy. And okay, so now at this time, I could go with higher quality. Let's go with medium quality first. And at this point, we'll probably get a better idea of the bump and see if that's actually fairly good, or is it too intense? Is the value perhaps in need of reduction? Oh, it's okay. Okay, we're starting to see the features from the height map much better, but it's nice to see a bit of dirt or a bit of noise. It looks like there is some disturbance there. What else could we possibly want to do here? Perhaps increase the wavelength, the height even more. Um, let's give it a 16, very high waves. Perhaps even enable the multi-frequency here. And then the AA steps, you know what we could do actually is simply switch it to high quality rendering. And then if we still need better quality, we can increase the anti-aliasing step, so we can increase some other parameters like the ray step. But here we go to high quality and it will trigger a rendering automatically and now starts to render. All right, so this will probably take into the area of about 10 to 20 seconds for each pass.